All right, then let's get to it. Okay. Yep. So as advertised, the goal today is to get you to learn how to take standard form quadratic equations, functions, and convert them into the kind we learned yesterday. Yesterday was a quick in and out, man. Like that's a simple lesson. Graphing in Vertex is one of the easiest things. It's obviously difficult if you still struggle with like finding 2/3 of 9 or what's 4/3 of 4, stuff like that. So when we modify our ups or our downs, if that's your struggle, that's just a basic math issue. I can help you, but that's not really algebra 2e kind of stuff. So at this point, we assume you know how to graph, like doing the negative b over 2a. We assume you know how to graph when it's in vertex form. And then today, we learn how to take the poopy ones and make them into the good ones. That's the goal. So I have like there's a 6 examples. I don't know. Maybe we'll have more, but probably 6 would be enough. We'll see. So our first example will be this. I maintain that even in a simple case like this, like if I asked you to graph this one, this is pretty light work. This one you'd make very short work of. Like the negative b over 2a would take like 4 seconds. Putting it back in would take maybe 7 seconds, and then you'd be good to go. So this is where you're closest to making a strong case for it's almost not worth the effort. But I don't like I just like to convert things into vertex, and you will too. It's not bad. Assuming you're good at completing the square, that's going to be the key here. So I'm going to walk you right through the steps. Um, I hope it all makes sense. I've taught this enough times where I think finally I know the right way to do this. There was a period before where I kind of was like, maybe we should do it this way. Maybe we should do it this way. I'm like almost completely off that side of the fence that leads to let's do it this way. So here we go. So the first thing you're going to do is um, you're going to leave the x squared and the minus 10x, and you're going to put the plus 15 a little bit off to the side like that. Now this step, this what I'm asking you to do right now will become more important after example 2. Like the first 2 examples are just our warm-ups. But what happens is sometimes there's going to be a number right there. And again, this will make more sense when we get to like 5 minutes, 6 minutes from now. You're going to want to divide these 2 terms, only those 2, by whatever is in front of the x squared. Okay. And by divide, I mean like factor it out. So in this case, again, that might be confusing because it doesn't really pertain to this. So it'll make more sense when you see it. But just know that that's something that we're bypassing because there is nothing in front of the x squared. Just FYI. So what we're going to do is instead of worrying about that nonsense, we're just going to do a very simple completing the square. So what is half of minus 10? Right. And negative 5 squared is 25. So I'm going to add 25 right here. Now, normally what you're accustomed to is when we do this the old way back a week or so ago, or 2 weeks, I don't remember when it was, we would usually follow this mindset. If I add 25 on this side, then I have to go to the other side of the equals and add 25, right? What we're going to do here is instead of that, we're actually going to erase our footprints. You're going to hear me say that a lot. And what I've done is I've completely broken this equation. Like you can't do that. You can't just add 25 because you feel like it. And then I say something like this. I can if I turn around and I wipe it out. You think about that, look at the 2 red numbers on the board. This will be really key. What have I accomplished by putting those 2 red numbers? Nothing. Good. I'm so glad you said that. Adding 25 and subtracting 25 are complete dead opposites. And so the minus 25 is the footprint eraser. He's the guy that comes up behind the 25 who made a mess and says, I'll erase any evidence that you were ever here. Which of course then begs the question of, well, why would you do it if it serves no purpose? It doesn't serve no purpose. It just mathematically is a wash, right? The purpose is this. What is that? It sure is. It's a square. Just like it's always been, we just completed a square. So now, instead of that thing that I have underlined in purple, I'm going to write it like what Cooper said. I'm going to write it as x minus 5 squared. By isolating that little 3-term chunk of the right-hand side, I have a square. And you already go, hot dog, it looks just like vertex form. Yep, I know. And then you got to do a little bit of little kitty math. And the little kitty math will sometimes be third grady like this, and sometimes it'll be more sixth grady with fractions, but it still is just math, right? What is 15 minus 25? And there is your vertex form. Done. Got it? I purposely put one more easy one like that for our second example. Hopefully that felt kind of good. Hopefully you're not staring at it going, what in God's green earth just happened? Again, I add a number in a particular place to complete a square, but then since I'm doing all my work on one side of an equal sign, I'm not doing, you don't want to add 25 to the left. Holy God, because then y is not by itself. It's not in function form anymore. You've made a mess. So since we're doing all of our work on one side, we have to put one number there with a purpose and then another number just to erase his tracks. Got it? That's the idea. So there you go. That's vertex form. Done. Let's go and do another one. Everybody okay with that? That feel good? All right then. Let's do y equals x squared plus 12x plus 29. What's step one going to be? Yeah, let's create a space, right? And this, by the way, this creating of the space is what I've waffled back and forth on over the years. There are those who look at the 29 and say, I just wish the 29 were a 36, and they can work around it. I've just found, I'm a play the odds kind of guy. I found more success if I just clear a landing zone for the whole 36, right? So rather than trying to turn the 29 into a 36, which if you find that that's your sweet spot, you can do it that way too. Just again, playing the odds. What I found to be most successful with Algebra 2 students is just to clear a space, clear it out, and keep it clean. Okay. So I've already heard you say 36. You've heard me say it. Half of plus 12 is plus 6. Plus 6 squared is plus 36. So I'm going to add 36. And then to erase any evidence of the fact that he was ever there, what do? I turn around and I subtract 36. Those two red numbers are complete opposites. Therefore, it's like they have no net effect at all. Yes, sir? You're fine. It's just completing the square. What's half of plus 12? Plus 6. And what is plus 6 squared? So that's that completing the square algorithm that we've done before. Half the middle, square it, add it in there. Good, good. And again, this thing that I'm underlining in purple, the longer purple underlining is a square, right? That we did it, we built it, we finished it, we completed it. And so when I write it out as a factored form of himself, what is he? He's x plus 6 squared. And then as always, we hope you can do little kitty math. What's 29 minus 36? And there is your function written in vertex form. And even in a case like this, I don't think I'm wrong to say that that's as easy as a graph could get. Like if you went back in time a week when we were graphing in standard form, even if I gave you something this simple, which I stopped doing, right? I started giving you more annoying ones over the days, like started throwing fractions and odd numbers and stuff in there. Even if I gave you something this easy, I still think it's quicker to convert it to vertex form than to do the negative b over 2a, figure out what that is, put it back in, get the y. Like but listen, if you do the other way, if you do negative b over 2a, it's still going to work, right? Like, could you tell me from looking at this, I'm going to put a box around it. Can you tell me from looking at this function in the green box where the vertex of this parabola is? It is this is what yesterday's work was for, right? So we didn't have to mook around with silly stuff like that. The vertex is clearly at -6, -7, right? But if I was doing it the other way, it would still work. Like if this is my b, what's negative b over 2a? It's -12 over 2 times 1, which is 2, which is still -6. But look, I still got to plug that -6 back in, right? What's -6 squared? 36. And what's 12 times -6? -72. What's 36 minus 72? That's right. It's negative 36. And what's negative 36 plus 29? Yeah, newsflash, it's still negative 7. You can't really get away from the fact that this up here just is more pleasant, I think, than dealing with all that annoying arithmetic. Yes, ma'am? Do we have to do standard form or test? Your test will consist of showing me that you know how to graph when it's in standard form. Sorry, it's in the standards. And showing me that you know how to graph when it's in Vertex. And then there'll be a big chunk of just convert standard to Vertex. Okay, good question. So far, so good. Okay. So now things are going to change a little bit and we're going to get rid of the warm-ups, and it's still not hard. I just need you to know that there's just a little bit more, there's a few more opportunities to mess up when it's all about the first number, right? If the first number is not just a 1, there's a little bit more meat on the bone. So let's say we had negative x squared minus 6x minus 4. Right. Listen, we are never, ever, ever, with a side order of never, and to drink a large frothy glass of never, going to do this with the mindset of do something to both sides. You cannot mook up the y. Having y equals is what makes it a function form, like a graphable equation, right? The moment I apply an operation to both sides, it's over. And then I'm going to have to move that operation right back to get y back by itself again. So never are we tinkering with the left side. Everything we do is over on the right side. We're just playing around here. So as I said earlier, I pretty well kind of told you what was coming. This is our problem right here. And nothing else. It's him. So I'm still going to follow kind of my own advice. I'm going to leave the y in the equals, and I'm going to leave the negative x squared, and I'm going to leave the minus 6x. But just to clear a little bit of a place, just to get it out of sight, out of mind, I'm going to take the minus 4 and move it out. By putting minus 4 over there and time out, I'm effectively reminding myself also that what I'm about to do does not apply to him. Okay, he's off. He's over there. I'm saying, go play on your phone, take a nap, go grab a couple crackers, whatever, just take a break. I'm about to mess around with the first 2 terms. Now, what I want to do is I want to pull out a common factor. And in this case, the common factor is going to be determined by what the leading coefficient is. You've heard me say this before, that I don't really care if everyone agrees or cooperates. Like the 6x, your opinion is not welcome, 6x. I'm not asking you if you want to play along. I am going to divide you by a negative, regardless of whether you want me to or not, because I want to get the negative off of the terminal. So if the 6x were like a 5x and I was about to divide by 2, I wouldn't ask for the 5's input and say, well, I can't do that because 5's not divisible by 2. I give no craps. So I'm going to GCF out or factor out whatever is in front of x squared. So in this case, that means I'm going to write it as y equals, and I'm going to pull out a negative, and I'm going to reconstruct. Now, notice that my set of parentheses might seem a little bit longer than it needs to be. Well, that's because I want to leave room in there, that landing zone, that landing pad for where I'm going to complete a square. So I'm making room for 3 terms, even though I'm only mooking around with 2. So if I pull negative out of negative x squared, what's left? I just get x squared. And yes, if I pull a negative out of a minus 6x, he becomes a plus 6x. And then notice minus 4 is still over there, locked out of the cool kid club. He's still sitting over there in timeout. He has nothing to do with what we're doing right now. Got it? So far, so good. Okay. All right, it's time to complete the square. What you need to do at this point is put all the negative and the parentheses and the minus 4, put all of that out of your mind and focus solely on what's in the parentheses. What's half of plus 6? Plus 3. What's plus 3 squared is plus 9. So I am going to add 9. And what will erase a plus 9? Exactly. Another plus 9. Good. This is the part where you assume I messed up, and I like that. I like it because I honestly, yesterday, I think I counted 11 mistakes before the day was over. Yesterday was a rough one for me. This one was not a mistake. I just got done telling you that if you do something you have to erase it. And you might be looking at the board going, hey, a +9 doesn't erase a +9. This next 20 seconds is going to be critical. And we're going to have this conversation so many times. I'm going to point to a number and I'm going to ask you what it is. And I'm not having a stroke. What is that? It is a -9. Yes. So what it is that red +9, he's like, this is not my true identity. I'm like undercover right now, because really, if you take that minus sign that's in front and you distribute it across to me, like, keep it on the DL, I'm actually a -9. And so when I quote added 9 in the parentheses, what was I actually doing? I was actually net result subtracting 9. So when I go to erase his footprints, I think, oh, you're not really a +9, you're a -9. So to get rid of your tracks, I have to do a +9. You follow? Does that make any sense? Okay. It is kind of cool. That process, that long green arrow that you see on the board, is going to be the thing that determines how well you do on the next quiz. Mark my words. So let's get to it. We're done. We just have to put it all together now. So y equals the opposite of what? X plus 3 squared plus 5 done. Clearly, you can see it now with infinite clarity. It cleans up so quickly and so nicely. It's a vertex, obviously, with its it's a parabola with its vertex at -3, 5, and it opens downwards, and it's structurally not changed. It's still got its 1, 4, 9, 16. Good, good. Next one. Just trying to scaffold this up. Okay, the next 3 are just going to get progressively harder until we get to the point where I can't really make them harder than the 3 examples from that. So once we get it, we get it. So this one is y equals 1/2 of x squared minus 4x plus 12. So we want to be quite structured with the steps, the process. So going back to the last example, what was the first thing we did? Let's move that 12. That should just be a good first habit, is let's clear a little landing zone for the completing of the square. So let's say y equals 1/2 of x squared. Eventually you'll blend these 2 steps into one. I don't think now's the right time for us to do that. So we're going to leave these guys here, and plus 12, we're going to put on a little bit of a timeout there. Remember, plus 12 is out. Don't mook with him. Leave him alone. All right. What do we do next? I'm sorry, say again. No, but I would put 1/2 in front of a set of parentheses containing x squared. But you really are missing the boat if you put this here. Just, I'm going to put this and I'm going to unput it. Don't write it down. You always have to ask yourself, did I change something? Yeah, I did. If I were right now to distribute this, and again, I'm writing things that I'm going to unwrite because I just having a little side conversation. If I were to distribute the 1/2 right now, I need to make sure that what I get is what I had before, right? That's the rule with factoring. If it doesn't equal what you started with, you didn't factor well. What is 1/2 of -4x? So it doesn't go back to equaling what I wanted. Therefore, the -4x has no place there. So I am going to leave the x squared, but now let's have a conversation about what goes here. Yes, it is -8x. And there's a couple schools of thought on this. Thought number 1 is have the conversation with yourself that I just had with you. Put something there and take it for a spin. There are some people who say, well, 1/2 of 4 is 2, so I should put a 2x there. But then those people should have the give a crap to say, Okay, let me multiply it back out like my teacher did. Let me take the 1/2 and multiply it by what I put there. And I go, oh crap, 1/2 of 2 is 1. And that's when we realize that we need something that where we can say half of u is the 4, hence the 8. A more mathematical way to do it, I'll show you in the next one because it's going to be much harder to do in our heads. But for now, we can rely on, I think, what you did, and that's just simple, common mathematical sense. This has to be minus 8x. And if you wonder why, I can prove it to you as multiply that purple arrow right now. What do you get? It's exactly right. And if it equals negative 4x, then we put the right guy. Good. It bothers people because they think like half means something should get smaller. But when you're dividing by a half, you actually have to make something bigger. So that's that. So if you can survive that, that's another hot spot for mistakes right there. And a lot of red ink spent there every year. So we made it. We got that. And now the rest should be, I hope, relatively simple. And I get rid of this purple arrow. What's half of minus 8? Minus 4. And what is minus 4 squared? It is. So I'm going to add 16 right there. And I had my plus 12 on timeout. And what am I going to do to erase the 16's footprints? Nope. I'm going to put a minus 8. And again, it comes down to this. I'm going to point to a number and ask you who he is. What is that? What is that? The number with the green arrow pointing to it. What is it? It's an 8. And anyone watching this video would say, my God, are they all like smoking crack in that class? Are they pumping gases into the room? I get that it says 16, but it's not a 16 because there's a half. That yellow 1/2 says, I own everyone in those parentheses. And if you multiply me 1/2 by 16, what do you get? You get 8. That 16 is not a 16. Multiply it by the yellow number and you're like, oh, you're really an 8 in disguise. Hence the need to subtract 8 to erase his footprints and not 16. Got it? And then from here, this thing right now looks like a jumbled dumpster fire. But it cleans up and boom, you're done. So what is the final answer going to be? Y equals, thank you, Blair. Done. And again, it goes from messy to done in the blink of an eye. Vertex at 4, 4 opens upwards, slightly fatty. All the ups are half as much as they would have been. So far, so good. 4 down, 2 to go. All right. I'm going to pause the recording. I need about 24 seconds to actually make sure I did not write this one incorrectly. So I'll be right back with you. Feel free to visit amongst yourselves. Excuse me. All right, then. This is the next one. So this is where we really start to appreciate the process that we're learning today, because I don't want to do this one with the negative b over 2a. By no means will I even insinuate that I couldn't. I'm just saying I don't want to. Like I don't. So we're going to use our new mad skills to turn this into something much more physically attractive. That's a little easier to graph. So the steps don't change. Just FYI, you now know all the steps. It's just there's one little buried secret trick that I'm going to show you in this problem. You really need this secret trick unless you're some sort of wizard. There's a little magic. Remember when we got the 8 on the last problem? That's where the magic is. That's going to be the key. So let's get to it. Step 1 is to move the 41/3, put him in timeout. So I'll stick him off to the side a little bit, leave a space. And then step 2 is to pull out of the first 2 terms whatever the first term demands that you do. And this is where things get a little bit sticky sometimes. So we're going to say y equals 2/3. And then we're going to always have just x. If you don't get just x squared there, something's gone catastrophically wrong. Like you've missed the whole point of that step. Okay, this question mark here will be the source of our success or our failure. It's like, what do I put there? And again, some of you have very good mathematical, like good number senses. You see a lot of calculations and you see them quickly, and it's really cool. I need something to help me through this step. So I'm going to show you what to do. What it boils down to is you need to take these two numbers in the green boxes. And I don't know how you want to put this into your notes, but this won't be the last time that I draw this for you. You need to take that green box and you need to divide it by that green box in that order, hence my decision to use an arrow. So what we're going to do is go off to the side and do a little bit of sixth grade copy dot flop arithmetic and figure out a number. The answer to that division problem will always tell you what to put where the purple question mark is. So I'm going to take off to the side 20 thirds divided by 2 thirds. Okay. That's a good time to really put some trust in me and just say, okay, that's what I'm going to do. Green box up there divided by green box there in that order. First one divided by new one. First one. Okay. And then copy dot flop. And if I flop it, it goes back to something that Cooper already said. And again, it proves the point that some of us just see numbers differently than others of us, right? You see that? I don't think most people look at those two green boxes right away and said 10. I just don't know that that's like what most of us do. But sure enough, when I copy dot flop it, I see that the threes cancel, 20 and 2 reduce, sure shooting to the number 10. So the answer to that green box divided by green box division problem will always yield the number that you want to put in the center. That's obviously a critical number, right? If you're not sure, if you don't buy it, check it. Follow the purple arrow. Follow my purple arrow and multiply. Just distribute. What's 2 thirds times 10? Multiply it out. 20 over 3. Boom. Just like that. You like that? You can always prove that something was done correctly if you just work it backwards and get what you started with. So nice work on that one there, Coop. That was quick. I like that. All right, so I'm going to extend these parentheses out. I'm going to keep my 41 thirds in timeout. And now I am going to complete the square. What's half of plus 10? Plus 5. What is plus 5 squared? So I shall complete the square by adding 25. And of course, 15 minutes ago, we would have erased his footprints with a minus 25. But now we are stronger mathematical warriors, and we understand when I point to this number and ask you what it is, you don't say 25. What is he? What is that number? What is the number that I am pointing to right here? Just, it is 50 thirds. Good. I just want to make sure we only answer one question at a time. You guys saying negative, I know why you're saying it, but I just need to make sure everyone's on board. That number, the red number, is not actually 25. His true identity is revealed by multiplying by the yellow number outside. And 2 over 3 times 25 over 1 is 50 over 3. And now I'm ready to hear what you were saying before. How will I erase the red number's footprints? By subtracting 50 thirds. Okay. And at this point, again, it's going to go from an absolute disaster to a nice, beautiful, little clean, ready to go out to a nice restaurant looking equation. So it's going to be y equals 2 thirds times what? X plus 5 squared. And what is 41 minus 50? And negative 9 over 3 is the same as, and just like that, poof, you got vertex. Okay. I have one more example, and then I'm going to print / hand out your assignment. I do not expect you to get your assignment done. I just expect that maybe we'll have enough time to get like 3 or 4 problems done, which would be cool. So this last one really is just kind of the put it all together kind of thing. And again, I honestly, I'm going to pause again because I just still want to make sure I didn't mess this up. After yesterday, I'm a little gun shy here. So. Yeah, we're kind of done now. You should put that away and get back on track. Sorry, I should have said something like, "Hey, we're ready to go." Um, there you go. Um, First, what do we do? Yeah, clear some space, flip it over. Next thing we do, take the -3/4 out, right? So I'm going to use yellow just because I really want to draw your attention to this number. This number plays a critical role in the next couple of steps, actually. So I'm going to pull out the -3/4, and what goes first in the parentheses will always say x squared. Again, if it doesn't, what in the world did you do in the last step? You got to ask yourself, right? Okay, so again, the math of it, and it's not going to fail you if you follow it in the right order. What do we do? What math problem do I need to do to figure out what to write next? Nice job, you guys. 3/2 divided by -3/4, right? If you don't write that down, your notes aren't going to make sense to you. You're going to look back and go, I don't know how we got that. So that's why I keep writing that down. That division problem is the key right there. And of course, understanding sixth grade math is also a big helper. So yeah, we're going to copy dot flop. So we're going to leave the 3/2. We're going to change the division to times. We're going to leave it as a negative, but we're going to flip over the 4 and the 3. The threes cancel. -2. So I write -2x. And again and again and again, if that just doesn't feel right, if you feel like I think something went wrong, multiply the yellow number by what you just put and validate it and say, does it equal what I started with? All right, so I'm going to extend my parentheses. I'm going to keep 21/4 and time out, and then I'm going to complete the square. What is half of -2? -1, and what is -1 squared? +1. So I will complete the square by adding 1. I think I left a little too much room for that 1. He's chilling. He's got some space. He's vibing. And how will I offset that +1? Nice job. By adding 3/4. Someone walking in right now would be like, what are you doing? But you understand, again, it's about revealing the true identity of that red 1. He's not a 1. He's the answer to whatever he is times the yellow number lurking like a creeper outside. And when you multiply those, you see who he is, and then you erase it with the opposite. Works 100%, has to. And just like that, we have our vertex form. So y equals -3/4. Got it? What goes inside? X minus 1 squared plus 6. Perfect. You guys think you got it? All right. I think I'll just probably end the recording here. I'm going to have to print Mr. Prepared here today, and then I'll get those handed out. That's that. The axis of symmetry, this will be a 30-second recording. Well, no, it's going to take longer than that. The axis of symmetry is the line that runs directly up the center of the parabola. So like on this graph here, like let's just, for example, say the last one we did. Where is the vertex of this one here on the board? Right, so we would agree that the vertex is at the point 1, 6. So if I were to graph that, which you're not graphing today, FYI, but if you were to have to graph it, then you would go right 1 and up 6 and put a dot there. So let's just assume it's like right here. Deal? So that would be the vertex, and then the parabola would open and it would go downwards, and I'm not going to worry about the math on it, but it would look something probably like this, right? It would look a lot nicer than that, but that's the idea. Um, The axis of symmetry is a line that goes right through the vertex. Obviously, you can see why we call it the axis of symmetry. It sounds like it has such importance. It's the line about which the parabola is symmetric. And as you know from Algebra 1, hopefully you remember, I won't be offended if you don't. All vertical lines are written by just stating how horizontally they are or where they are. So like horizontally, where is this line situated? X equals 1 is the axis of symmetry. Done. That's it. So that is what the axis of symmetry is. It's the name of the vertical line that runs through the vertex. It would be really easy for someone at this point to diminish that and just say, oh, so I can just take this number that you just circled in purple and just write x equals that. Yes, that is correct. But understand what that is. The reason I'm doing that is because it's a vertical line that runs through that point with that x coordinate. Got it? So that's what the axis of symmetry is. If you say the axis of symmetry is 1, I'm going to kick you out of class. The axis of symmetry is a line whose name is x equals 1. We got it? Can I end the recording on that? All right. Double recording day. Mr. Aaron's a slacker.